So in this example, I'm going to use NoSQL Bench to kind of
Hello, Alex. Can you hear me?
Yes, I can hear you loud and clear, and I hope you all see us as well. How it goes,
Yeah,
everyone?
if you can get some thumbs up, if you can hear us okay,
Yes.
and see us well.
Loud and clear, loud and clear,
Excellent.
that's very good. And let's give people like 20, 30 people to jump up to the stream, and we will start.
Perfect.
Yes.
Are we ready?
I think so. It looks like we have many dozens people today, and everything is fine with the setup. That's incredible. Okay, so welcome to Intro to Cassandra for Developers. Here is Bettina Swinnerton and Alex VOLOCHNEV to lead you today through the workshop and help you with all the questions, but not only two of us, but actually a great team of the data stacks developers, community managers, and so on and so forth at day together with you. So
Exactly.
yeah,
Here's the whole crew.
yeah, that's incredible. So Bettina, would you start?
Yeah, wonderful. Well, thank you very much, everybody, for joining us today. So today we're going to talk about an introduction to Cassandra. It's a basic introduction workshop today. And but more advanced users are also welcome and help us answering questions in the chat. That would be wonderful. As Alex said, I'm Bettina, and I will do a lot of hands-on with you today, and I hope that you really join us doing the hands-on with us at the same time. That would be absolutely wonderful. And we're here, and we have a whole crew in the background to help you with your questions. And we're trialing something new today for taking some questions, and we'll introduce that to you in a moment as well. Okay. And obviously, thank you, Alex, for being here, our experienced Cassandra developer advocate. Wonderful, thank you. So today, just housekeeping. We're streaming today only on YouTube. Is that correct, Alex? We had some problems with
Yes,
Twitch?
that's right. We have some problems with connection to Twitch, so we stream only on YouTube this time.
And the video is recorded, so that's available in this YouTube channel after the, it takes a little bit of time for processing, but it's available afterwards. And so are all our previous workshop videos, so you can review them at your leisure. And if the video stops in between, you might just want to refresh your screen. We've had that a few times, unless we let you know that there's really a problem, but hopefully, fingers crossed, it's going to go fine today. We'll be working with Astra today. This is the, the database that you can play with today in the hands-on. So we'll encourage you to create an account with Astra and set up your database, and we will walk you through this in detail so that you don't have to do it right now. We'll get there in the hands-on exercises. We have the Discord channel. If you have really detailed questions, then the Discord channel is actually the best, right, during the workshop, because you can use Markdown, and you can, we can even have one-on-one discussions, and we can also continue the discussion after the workshop because your questions stay there, right? But we also monitor the YouTube chat. So you can put your questions into the YouTube chat as well, and it can become quite lively sometimes. So, as I said, we try something new today for answering questions, and I'll give you the link to that in a moment. And we will be doing quizzes. So for those who've been with us before in the workshop with us, we do a lot of quizzes, and they're good fun. Initially, we will do a survey to learn a little bit more about you, right? Where you're coming from, what you want to do, etc. What's your experience with Cassandra, for example. And then later on, we will test a little bit on the stuff that we've covered. It's not extremely challenging, but you want to pay attention and you want to answer pretty fast. And then you can actually win some prizes, some nice data stacks branded things that we will ship all over the world to those top 3 who answer our questions. Okay, so now before I go too far, I want to quickly show you what we're doing today, we're trying out a question app called Slido, and you can just take a picture of the QR code, and that allows you to enter questions, and we then see them, and you can vote up on other people's questions, etc. So we hope that we can group a little bit more the really urgent questions for you, or the pertinent questions that you want to get answered, and we will have regular slots throughout the workshop to answer your questions.
I would say what we in general always try to answer as much questions as possible, but sometimes we have so many of them, so the workshop would take 5-6 hours if we're answering all of the questions.
Exactly.
So we have a great team answering in Discord, preferably, and YouTube chat, which is fine as well. But if you want your question to be really answered in voice by Bettina or me or both of us during your workshop, you do want to use Slido.
Yeah, actually, it's a good point, because whoever is presenting is actually not watching the YouTube chat or the Discord, because it would sort of mean a lot of screen switching in order to see the questions. So I think they might scroll up the questions while you have them. So if you put them into Slido, we can then later on sort of see what the questions were, and we can more easily review them.
Yep.
Okay.
And the easiest ways to use Slido is just to use it on your mobile phone while watching us.
Exactly. And same for Menti, actually. You want to have your mobile phone ready, because it makes it much easier for you to answer the questions, especially when it matters that you want to answer fast, because the fastest correct answers will get into the leaderboard and have a chance of winning the swag. Okay, goody. So if you have questions after the workshop, right, obviously YouTube chat that expires, or the access expires as soon as the workshop session is over. So you can continue to use Discord. We are popping in and out throughout the day and address questions. But we also have our community forum, which is also hosted by us, and where you will find us again answering your questions. And we also can then make the answers and the questions available to the rest of the community, so everybody can learn from it. And we pull in a lot more other people, right, from DataStax and the wider Cassandra community to answer your questions. So that's a really good, think a little bit like Stack Overflow for Cassandra and Cassandra-related questions. And then there's tons of training available on Academy. And actually, we should probably put an icon here for the DataStax Dev webpage, where we have a lot of examples and a lot of further details for you to continue working into your developer journey with Cassandra and Astra. Okay. Good. So let's get started. Today, we're going to work with Astra, which is Cassandra as a service in the cloud. And you do not need to think of anything about installations or operations. That's all done for you. You don't have to provision an instance and then install Cassandra, etc., configure it. So that's done for you, and it's ready to use, and it's free of charge for you to use. There is a sign up required with your email address, or I think your GitHub account or Gmail account. But apart from that, it doesn't cost anything. You don't need a credit card, and you can quickly get registered. And you get a very generous free tier, which doesn't expire. There's no sort of 30 days or 1 year limit. It's limited by the amount of storage. But in our experience, this is plenty for getting started.
Cassandra is a very powerful distributed system, so you definitely don't want to put all the efforts you need to run it for a single workshop. So we prepared everything for you, and you can simply start using that.
Exactly. And while we're at that, actually, I think we want to give you an introduction to Cassandra in a moment, but let's give you first get an idea where you are, right? And who are we talking to? I actually have no idea how many people are watching us at the moment, so let's go to Menti.
So we have many dozens of people watching us right now. That's incredible.
Oh, perfect. Good. So let's try out Menti. So Menti is our first app that we're using in order to gather some input from you. So you want to go to menti.com, and you want to use the code 6088556. Or you can just go to use the QR code, scan it, and hopefully, if I did it right, it should get you to the same place. So 6088556. And give us some thumbs up so we know how many we have there. I see 7 so far. 8. Let me know, Alex, when it's because I don't know how many people are on the stream at the moment, when it would be good to sort of like get started with our questions.
Okay, I think we can start in a few seconds. That should be completely enough.
Okay.
Again, my big question for you, please do not answer questions in the YouTube chat, but in the Menti, we have a special app for that. You don't have to register, you just push the code 6088556. I'm doing that right now. And we are here. And let me move you a little bit. Yeah, so we have few dozens of people have jumped in already.
Okay.
Let's start.
That's
That's enough to start.
Oh, perfect. Good. So first question we would really like to know is how much experience do you have with Apache Cassandra?
Yep.
You know, we like to see that you've never used it because it's this is an introductory workshop, right? And we're delighted to see more people who have had no previous experience with it. That's wonderful. And perfect. That's great. Okay, so I move on to the next one. This is just for us to gauge a little bit the audience. Have you been to any of our workshops before? Okay, lots of newcomers. That looks great.
That's great. So what I have to say, you will love it because, well, our workshops are really well done and we always have some great feedback. And if you will like it as well, don't forget to subscribe. There is a button right under Bettina, subscribe. So push that if you like the workshop.
Cool, excellent. Okay, well, quite a few returners. That's also wonderful. We have sort of over the summer built up a really good family here, which is wonderful. It's so much fun working with our workshop audience. Cool. What's your main motivation for learning about Cassandra? Are you interested in developing? Are you interested in administration? Or is it both? So today, and also with Astra, we don't cover really any admin topics. I think, you know, the data modeling aspect perhaps I think is very useful as well for people who are mainly interested in admin. But I think we can still probably pick something up that you find interesting if you're mainly interested in administration. But we won't go really into, you know, managing and operating the Cassandra database. That's not part of this workshop today. We have plenty of other resources for that. So if you have any questions on that, just ask us. Cool. And how did you hear about us?
LinkedIn, Eventbrite always works good. Through a friend, that's my favorite.
You can subscribe to Eventbrite, right?
Yeah.
So you can subscribe, don't miss any of our future workshops.
Yep. YouTube through a friend, LinkedIn, okay, great. That's lovely.
Excellent. Perfect. And then what do you want to do with your new knowledge? What's your aim?
Answer, earn more money.
Yes, exactly. Get rich and famous.
Take a look, that's a workshop for developers, not for managers. So I hope there are no managers and I can clearly say, with my new skills, I want to earn more money. That's simple.
So it's so nice to see all these people who want to build an app with Cassandra. So if you build any app with Cassandra, let us know, right? Even if it's just a small example app, etc. I think we're extremely keen to hear what you're actually doing with it. And, you know, we're planning on collecting them and creating sort of like a sample repository. So, you know, just if you create something, let us have your GitHub repo where we can see it. And, you know, perhaps it's a good contender for our sample applications. So we definitely want to know about it. Perfect. And I think that was it. Wonderful. So let's go back to the presentation. I think, Alex, you might want to take over and show a little bit about...
I have to say a few words about that. And let me switch for a second from Bettina's slides to mine. Yes. Okay. So, take a look very briefly. Today we are going to work a lot with Cassandra, and that's for developers. So we will speak how do you connect, how do you operate with the data, and so on. But first, we anyway have to say a couple of words about what's the Cassandra and why we love it so much. So, Apache Cassandra is an open source, no SQL distributed database. And every word in this phrase is very, very important. You can use Cassandra as a single running instance like you use it to do with many relational databases. And it's going to be a pretty powerful setup, well, depending on your server or your laptop, whatever you are running. But that's not the point when you run Cassandra, because usually you use Cassandra in the proper way, and that's a distributed system which shows all the power of that setup only in the distributed mode, of course. So usually we speak about the multiple nodes, and sometimes it can be a really big numbers when you work with a very big data, of course. Every node communicates with every node. There is no thing like we used to say master-slave, now we prefer to say primary, secondary nodes. No, every node has the same responsibilities and the same duties, and they all communicate with each other via gossiping. There are no single point of failure, but they all work together. And all together they group a data center or ring, which is basically the same, handling the requests and answering your queries. The main features of Apache Cassandra you have to remember when you think of why it's great and what makes Cassandra so powerful. It's big data ready. From the very beginning, Cassandra is big data ready and ready to work with any amounts of data. For example, Apple reports Cassandra usage speaking about dozens, maybe already hundreds petabytes of data. But that's not the only big deployment, because Cassandra is widely used by Netflix, for example, or Instagram, Huawei, and many other big companies. It delivers highest availability on the market, basically, because of some powerful features we are going to show you in a second. Geographical distribution. You may have multiple data centers within the same cluster all over the world, and even if one region is completely not available, other regions will take care of the data and will respond to your queries. So the highest level of disaster tolerance, for real. Geographical distribution, yes, that's very important also if you want to keep your data close to your customers. If your main server is in Europe, for example, but your clients in Australia, they are not going to be happy. With Cassandra, you keep your data close to your clients wherever they are. Highest level of read-write performance. A lot of the databases may deliver high level of read-write performance at first, in the beginning. But as soon as your data starts to grow, and we speak about the terabytes, hundreds terabytes, petabytes, well, that's not going to behave so good. Cassandra still behaves perfectly, even under highest pressure, handling really huge size data. And finally, it's an open source platform independent Apache Foundation project, heavily supported by DataStax, of course, but also by many other companies. So you may have it on every platform, in every cloud, and you don't stuck dedicated to one single platform, as it may happen with some cloud providers. First thing, like how it works. Okay, Cassandra is great, but what makes it so great how it works? First thing, it scales linearly. It means we have zero to a very low overhead on adding new nodes. You have 3 servers in the beginning and your data works perfectly quick, that's fine. But now after a few months, for example, your application grows bigger and bigger, you have more and more customers, you have more and more data. Adding new node is very easy with Cassandra, and that's for a Cassandra cluster to take care of the data distribution and many other features. You just plug in new server join a cluster and data is reshuffled, and now boom, you scale more and more, higher and higher, and you can handle higher throughput, or you may have more capacity. Just plug in your server. But it also works another way. Let's say Black Friday is over and your company is heavily briefing that you survived successfully. Black Friday, or I don't know, Christmas sales, whatever you have, whatever the hardest point. Do you still want to pay for the servers in, let's say, your cloud environment, for example? No, you don't, because obviously the workload will be a little bit lower in the upcoming days, weeks, till the next peak. So what do you want to do? You want to decommission the server, and you just plug out the server, say, hey Cassandra, we aren't going to have so heavy load anymore, so let's take this node down, and this node is down, you decommission the server, you pay less for the same database infrastructure, and that's lovely. Second thing, how it works. Data is distributed. There are a lot of definitions what the big data is, and they try to cover the situation and this definition from very different sides. The one I like, simple and clear. Big data is the data which doesn't fit a single server anymore. It's not like the most scientific explanation you would find, but it works very well. And in general, when you work with relational databases and you may want to have your data everywhere, as long as your data is too heavy already, your database doesn't work so well, and then you have to start sharding. And sharding is very painful. If you ever did sharding with relational databases, you exactly know what I mean. If you didn't, you are lucky. Please believe me. So, Cassandra works in a different way. We know what we are going to work with the big data. And to avoid any potential problems of growing this data more and more, Cassandra uses partitions. Based on some fields, columns, you dedicate it to give a partition key, like country in this example. So we have a table storing value of amount of people per city, per country. We decided to use country as a partition key, and it leads us to a situation what the data is spread onto multiple servers completely automatically. You don't have to care about that too much. That's for Cassandra to spread data over the cluster, and you will have it evenly. And if you need more disk space, just add more nodes, and that's very fine. But another thing which is very important, data is replicated. What does that mean? Every record of your tables, every piece of data you store is replicated accordingly to your settings. This setting is called replication factor, and replication factor defines how many copies of this data you are going to have per data center. So, for example, if you have multiple data centers in Europe, United States, India, Australia, and so on, you can decide what this one is my main one. I want to have 3 copies there or 5 copies there. And this one is like secondary for some failover scenarios or maybe for analytics workloads. So I don't need to have any replication factor. I will set it to 1. Obviously, replication increases disk space consumption, but you know what? I don't care, because disk space is cheap, but the availability and the reputation of your company, that's what matters. Okay, so how does that work? With replication factor 3, then some data comes, it will be spreaded by the node which received the request to all the replica nodes. Replica nodes are the nodes responsible for this partition. And data is spreaded to the proper nodes. Again, there is no primary and secondary servers. As long as you have a node in your cluster, this node is ready to answer any kind of request. Doesn't matter if this node stores this data or not. If it stores, it will dispatch. If it doesn't store, it will ask proper node. Cassandra cluster is very smart, so you have everything you need, and every node knows exactly where is data stored and whom to ask without any additional, do you have this data, maybe you have this data? No things like that. It's just a direct question to a proper node. If anything goes wrong and one of the nodes is not available, network is down, power is down, or maybe you have a scheduled upgrade, changing something on your server, doesn't matter. The node what received the request, it's called coordinator. Coordinator sees what one of the nodes doesn't confirm the data received. It will store a hinted handoff file, and as soon as node recovers, this hinted handoff will be delivered to the failed node, so everything is recovered. But Cassandra is a very, how to say, resilient database, so that's just one of the very many mechanisms of self-defense if anything goes wrong. You know, as long as you have a distributed system in the network infrastructure in the cloud, networks are pretty hostile environment, let's say, in the clouds. So Cassandra is ready for that completely. Now, many people ask, as long as I have multiple copies of my data, it brings me to a problem. It may happen that somehow your hinted handoff didn't work. And now I have some nodes updated, some nodes don't update it, and you know what? I don't want my data to be not up to date. I don't want my data to be not consistent. Okay, it's all solved, and many people call Cassandra AP, available and partition tolerant, but not consistent, or eventually consistent, and I don't like this definition, because you may bring Cassandra to this state if you change some of the settings, but as long as you work with the default settings, it says use consistency level quorum. What does that mean? When you store the data or when you retrieve the data, you don't just get your data from simply the closest node, but we enable a quorum mechanism by default, which asks all replica nodes for the data, and if data is matching and everything is fine, we will deliver the response, or therefore store it. So at least 2 of 3 nodes, if you have replication factor 3, so majority of the nodes will be updated. But if you don't have this quorum reached, when Cassandra informs you like, okay, we have a problem here, but you can afford using quorum, you can lose the minority of the nodes and still have your data fully available. And that's great. And then you write with consistency level quorum, and you read with consistency level quorum, you always get consistent, up-to-date information for a very simple mathematical reason. If out of 3 nodes, at least 2 was updated, and then you read from 2 nodes, you get your most up-to-date answer always. If you asked for 2 up-to-date nodes, you get your data correct. If you ask for 2 nodes and one of them was not updated for any magical reason happened, that's again very fine, because Cassandra not just returns your data, but compares, checks the situation, returns you up-to-date, consistent, fully consistent value, and then what happens next? Again, next layer of a self-defense, so we have repair and read mechanism. So again, with the default settings, you are consistent. Oh, I just explained this part. And final thing I really like is that absolute geographic distribution and platform agnostic. You can run Cassandra on multiple data centers all over the world. You can form a single cluster from them. And data is everywhere in the United States, India, Europe, China, Australia, South America, and so on and so forth. And that perfectly works together. Active, there are no problems like this data center is active and this data center is read-only. No, all data centers are active. But also, not only that, you can have your data and you can have your cluster running at the very same time at AWS, Google Compute Platform, Microsoft Azure, your own data center, and those will be the single cluster over multiple platforms. So hybrid cloud, multi-cloud, it all perfectly works with Cassandra. So as you see, Cassandra is pretty advanced system. Speaking about the use cases, in general, the main things when we start to think about Cassandra, everything what relates to highest throughput requirements or big data, and everything what relates to scalability. You have to process a lot of data, very fine. You are going to have 5 times more visitors, guests, clients, customers on some particular dates. Scale up, no problems. Again, availability. you can afford losing servers as long as your quorum is operational. You will be fine. And that's very good for every kind of a mission-critical data storage. Distributed workload mobility. You can have your different kind of workloads on different clouds using hybrid cloud. And global presence data is available everywhere. And finally, everything what relates to cloud native. Any kind of modern cloud applications, Cassandra is perfectly runs in any kinds of clouds, and that's one of the strongest features we can provide. Whew, and it looks like it's exercise step.
Awesome! Something to do for everybody.
Yeah, so I'm speaking and speaking, and that's your time to do some work.
Speaking and speaking. But now everybody can try out Cassandra.
Yeah.
So I think that's the whole point
That's great.
today. So, but thank you so much, Alex. I think it's really good to have a a bit more of a conceptual understanding what we're actually going to play with today, right? So
should I switch to your screen?
Yeah, let's do that.
Give me a
And then
second.
I show everybody how to get started with Astra, huh? Okay, let me know when I'm back on.
You are back on.
And I apologize, there was a comment about me trying to, I should switch off my mic, which I won't because I'm speaking. And I am a very loud typer. I really don't know how to make this quieter, so I'm sorry about the keyboard noise.
Now is my time to answer questions, and I have very loud keyboard, so it's revenge time.
That's wonderful. Okay, so how to get started with Astra. So I think everybody should have the link to sign up with Astra, which I think we had it right in the beginning of the presentation. I should have. Oh, actually, let me show you this one here. Let's go to the GitHub repo first, right? So this is the GitHub repo, Intro to Cassandra for developers using DataStax Astra. And I made it really big in the font. I hope everybody can sort of see, perhaps not read all the details, but see where we are. And we basically there were some questions. Can we get a slide deck? Yes, you can have that here, even though Alex added these Cassandra slides just today, so we will probably have to update the slide deck. And then we're going to do today, we're going to create the Astra instance, and then later on we do some table creations, and then we play with creates, reads, updates, delete operations. So for now, let's just focus on the first one. So you can create your Astra instance. You can go to astradatastax.com, or here's another link to the registration page. And then you should get sort of like a screen like this, which I'm already past this screen, right? Because I'm already registered. You can sign up with your email or with Google or with GitHub. If you sign up with email, make sure that you choose an appropriate password, right? So it should have uppercase and lowercase letters, at least eight letters, and a number in there, and probably also a special character. So because otherwise you might not be able to create your user there. And yeah, so give us a thumbs up when you're basically coming to that page, which is the dashboard. And there we're going to create the database. So I don't know how long I should wait now. So I don't want people to miss this important step. So how you add the database. So in the left-hand column here on the UI, you have the option here to add database, or you can use it right, this button on the right-hand side where you add your database. And this gets you to the ability to choose your plan, right? And today we want to select the free plan, right? Because we don't want to pay anything, and we just want to use Astra without any obligations and get the free storage, and it's free forever. If you do that, the only option actually is to host it on Google Cloud. So this is the agreement for the free plan. If you were going for any of the production workloads, you could choose your provider, AWS, Azure, or GCP. Please select a region. I'm based in Europe. If you're based in India, we probably also recommend Europe West. And yeah, so that's the running cost, nothing. And then you click on configure, which is right. I don't know whether you can see it or I'm sitting in front of it. It's the button right in the lower right corner. Click on configure and that gets you to the database screen. And so we have given you some ideas what you should put in there today, and we kind of ask you to stick to those, but you don't have to, right? It just might make it easier later on following sort of like in copy pasting examples, but you can really use anything. We will use this key space name, killer video. So this will actually in the copy paste example sort of like really, you know, cause you some inconvenience if you use a different name. But other than that, you can definitely choose what you like. And okay, so this is how we do it. So killer video cluster. I've used that a few times before, killer video. And then KV user, I think I might have to update that because I never had a number in there before. And now you need to have a number in there. So make sure you type the same password, and then you can create the database. And this takes a little bit of time. So you see a status of pending for a little bit. And then let's have a look. I think David had some feedback. Yeah, I'm not sure what the question is. Alex, do you know what the question is about choosing a plan page? That should be right. If you're on the choosing the plan page, you choose the free plan and make sure you choose the region, and then you can proceed to creating a database. If you already have a database, if you created one before in a free tier, you have to continue using that, right? Or you have to terminate it and create a new one. You can only have one database in the free tier. Good, okay, so that's active, right? It's nice and green here. So this database is active, and now we can actually connect to it. Do not park it. Some people did that yesterday. Parking is that you're basically deciding, I won't use it for a while. And unparking can take some time. We don't want you to be stuck waiting for it to unpark. So don't do this for fun just now, because we want to start using the database. But that's basically how you set it up. And then when your database is active, you can go to connect, right? So you can click here. And you actually also see your databases then here on the side. You know, this was the killer video cluster here on the left-hand side. And what we're using today is there's different ways to connect to your database, right? So you can, you know, we have some prefab APIs for you here to update your tables and select. For example, REST API, GraphQL, we can connect with a driver. We can download all the credentials that we want to use in order to connect from anywhere to our database using a multitude of drivers. Or we can connect with DataStax Studio, which is a developer tool like Notebook, like similar to Jupyter Notebooks, if you like working with this kind of environment. For the tests or for the exercises today, we will use the CQL console. And the CQL, that means Cassandra Query Language. That is a language which looks very similar to SQL. And we have a console here that allows us to connect to the database. And now you need to enter your same user credentials that you set up just before. So KV user. And then you want to wait a little bit for the password prompt to come because it brings the node up and it exposes it. So that takes about 10 seconds. And which always feels very long when you're showing something. And there it is. And then something that came up yesterday, you won't see your password as you're typing it in. This is really standard Linux shell behavior. But if you're not used to that, it might throw you a little bit. So just type your password in and hit enter. And this is a successful connection. And I see that I can make that a little bit bigger.
Yeah,
what do you think?
Good.
Is
yeah,
that
I think it looks very good now.
Very good. Excellent. Good. And that's really as far as I wanted to take everybody in the hands-on. So what do you think? Do we need to give everybody a couple of minutes to complete that step? Or do you have any indication whether it's looking good for people? Give us some thumbs up
Yeah,
if at this step.
I see more and more people are confirming what they are fine. Connected. This was smooth. Good. Does
Very
the
nice.
free tier have any CPU constraints? Well, in short, obviously, free tier is not for heavy loaded production application. You would not run, I don't know, Amazon online store using the free tier, definitely. Yeah. So yes, there are some
Let me show you a few
limitations.
things actually while we're here. So you can go back to your summary page, right? And then you see actually a few limitations of the free tier, right? So, you know, for example, we only have a replication factor of 1 for this. This ties actually nicely into what Alex explained earlier, right, with his overview. If you went for a production tier and deploy the production database, then you can have a higher replication factor. But for the free tier, it's basically a single node with a replication factor of 1 that you have. So just that you know about that.
Sorry, Bettina. I see some people in the chat having exactly the problem you just explained. Please pay a little bit attention here. Then you type the password, no characters will appear. That's typical standard Linux behavior, standard behavior of a Linux console. Just type the password, press enter, and you are logged in.
And hit enter. And yeah, that's fine. Just, you know, you just pick a password that you can type blindly. without the feedback. Yeah, that's it is standard Linux behavior, but if you're not used to it, it might be a bit confusing.
One more question. What does key space mean? So it's very easy to explain. Key space is just a group of the tables working together. So like in some relational databases, you may have database and table within, or in Postgres, schema and tables within. You may consider key space like Postgres schema. So that's a group of the tables with some shared settings for them.
And for example, you can do a describe key spaces. And you will see that we have our specific key space that we set up, the killer video, which will contain all the tables that we want to work with. And then you see that we actually have some system key spaces, which, you know, because Cassandra is also used to store data in order to work with Cassandra, right? So we're using that. And, you know, so that's a nice way of keeping those tables separate, right? So we will only, this is a user key space, for example, the killer video, but these are system key spaces and we don't want to touch them, right? We don't want to do anything with them. But if you want to later on, if you want to experiment with that, right, you can actually add additional key spaces. So you can add another one and you can set up a separate app, right? You can, for example, say, oh, I do a to-do app, right? And then you add your key space there and then you can keep it separate, right? The connection credentials remain the same, right? So you can basically connect to one database and it basically has two sort of application key spaces. So that's entirely up to you. When you do that, you get this little sort of orange thing for the maintenance, right? That its maintenance is in progress. And, you know, once it's set up, that should come back to green and then everything is fine. Cool. Any more questions? We can have a quick look.
We may have a quick look on Slido. And there is two questions I want to address right now. First one, why is 1 GB is used by default? 1 GB is not used by default. It's a bug of visualization. So you have 5 GB free. It's just an issue of how it's visualized data. It's to be fixed in next week, maybe.
It's a quantification error, really. I mean, it's a very large bucket. If you're using less than 1 gigabyte, we're in the first gigabyte bucket.
Yes.
Right? I had a lot more key spaces yesterday on my Astra. I set up a new one and I had 2 GB because I had a lot more data in there. But so you will see it move up if you start filling it with data. And come back to us when you're close to 5 GB and let's see, you know, what you've done with it.
Cool. Indeed. Okay, so let's switch to Slido. How it goes with Slido?
Yeah, so I think the first one I hope we've answered this question, how to access Astra and deploy
Yeah,
it,
looks like.
right? So I think that's basically it. So you should all be on Astra. So I'll mark that as complete. And this one, very helpful. Thank you very much. Someone helped with that link. That's the main event. YouTube streaming is the actual event. Yeah, that's
just a second.
So,
There can be one not obvious thing. If you are watching it at the 1st of October, then that's the live event, and we are reading your questions in live chat or in Slido and answer them. And if you are reading them, if you are watching that anytime later than 1st of October 2020, then mostly probably it's not a live event. But there is a thing.
2050.
Yeah. But there is one more thing. At your YouTube, you may have a live button, and if it's not active and red circle, it means what you are watching it live. And if this button is active and no red circle next to that, it means what your YouTube, your personal YouTube, is on maybe on a bit delay. To switch off to the most up-to-date stream, you have to push this live button, so you have this red circle active. I hope I've answered that.
Oh, okay, yeah, I hope so. So I'll tick that off. I've been wondering why it's a bad idea to use network-based storage like SAN in Cassandra. That's a good question.
That's a great question. In short, in 2 words, don't use network-attached storages with Cassandra. Cassandra takes care of data replication, distribution, and so on. And in general, you want your Cassandra to be to use directly attached disks. I hope I've answered that. We don't have too much time. We have to move on, actually.
Okay, let's just do this one. So Cassandra Cloud Hosting Cassandra is not a cloud hosting service. It's not a service like AWS or Google Cloud. But Cassandra is a database technology. And Astra today is hosted Cassandra in the cloud, right? But Cassandra itself is not a cloud hosting service. And Astra is Cassandra as a service deployed and you have several options, GCP, AWS, Azure, but you can actually deploy Cassandra on any kind of cloud, right? So that's not restricted to those.
Yep. Okay, then let's move on.
So let's move on. Okay, so let's right. So let's talk about data and how we want to store the data in Cassandra, and then also go into the art of data modeling. And let's start with what actually we are holding. So this is the most minimum element of data that we're storing in a cell, which is the intersection of rows and columns, right? And here in this case, we have the name John in there as string, right? So that's the very, very most fundamental data structure. And then they're grouped into rows, which are single structured data items in a table. And, we say structured because each of those columns would have a type associated with it as well, and a column name. So the next row in this table would have the same structure. And then a very important element when we talk about Cassandra and how data is stored in Cassandra is the partition. Right, so that's a group of rows that have something in common, right? They have the partition key in common, and that sort of groups them together. And that ensures that they're stored together on disk as well, which makes it much faster to read those related rows, right? So we will talk a lot about the partition key because that is really that's your main control, how you're partitioning your data in this distributed environment. And how you want to balance it across the various nodes that you have. In this case, the partition key is wizardry, it's the department, right? And so in this case, those rows are grouped together by this partition key. And the partition key is not something that is automatically created, like an ID or something. A partition key is an element in your data. So, you basically decide which of your columns in your data structures makes sense to use as partitioning. So it's any element of your data. It doesn't have to be something which is consecutive or numbered or of a special format. It can be anything, really. And so we will talk a lot about that today. And then the next thing that is an important topic, of course, is the table, right? And we will create tables, and obviously in your key space you will have a lot of tables in order. In Cassandra you will have probably more tables than you thought you might need, because we will advise you that you want to basically create for each query that you have coming into the database, that you might have a different table for them in order to service the query as optimally as possible. And that the idea here is consecutively numbered, that's really just that's not necessary. That is just sort of a choice here in this example. And I personally actually don't like this, because we don't need to have any consecutively numbered IDs when we talk with Cassandra. And that's what it looks overall. So this is a key space. As we said, the key space is sort of a logical grouping of related tables. And then you would have in there your tables. The tables sort of like are structured with typed columns. And then you group several rows together by sharing the partition key. And that's really the most important about the Cassandra storage in a nutshell. Okay. Good. So let's look at an example, right? So we have here where we say our partition key is going to be, we're storing users by city, right? So we want to have the city, we want to have their names and their addresses and their email addresses, and we want to be able to retrieve all users that live in a certain city, right? It makes sense for us to sort of like get them all in one swoosh, and in this case it makes sense to partition them by city. So we say, okay, we group all users into the partition Phoenix. That's the partition key. And then we have the last name and the first name, the address, and the email. And there's a couple of things that we will introduce in a lot more detail on the next slides, important sort of like terminology. So this one is the partition key column. And then we have clustering columns, and they play a special role in our data retrieval, basically, in how we want to select data and how we want to get it back from the database. So we'll talk quite a bit about those. And then we have sort of like standard data columns, right? It's just all the rest that we pull out with a row. And in Cassandra, we talk about this as being a row, right? So makes sense in this kind of model. You have sometimes here the concept of wide rows in Cassandra, because you can basically attach and attach and attach to a partition. But this is really, in the context of today, that's what we think is a row, right? So like one unique record within a partition. And this is how the table creation statement would look in Cassandra. And if you're used to SQL, it doesn't look really that unusual. So you have your create table, and then you specify the key space name and the table name, and then you have your typed columns. And this is the important bit for Cassandra, right? First of all, every table needs to have a primary key. And the primary key always needs to have a partition key. And it can also have other key elements, right? In this case, it has 3, last name, first name, and email. And these other elements in the primary key are called clustering columns, right? And we will go into the details of these terms. But this is the main takeaway. Every table has to have a primary key. And the primary key is composed out of user data, right? You see here, we use the city, we use the last name, first name, email. As I said, no consecutive numbers or anything. And every primary key needs to have a partition key, because you always have to tell the database where to store the data in the distributed environment. So primary key that ensures the uniqueness. It's the identifier for a row, right? So it's, as I said, it needs to have at least one partition key, right? It always has only one partition key, but you can put the partition key, you can compose it out of several columns, but that would make sort of like a composite key. And then you can have additional columns in there and they will help you with ordering and sorting. So you want to make sure that you have uniqueness, right? Because two rows with the same primary key will override each other, right? So that's what you need to think about. So if I have, for example, just city and last name and first name in my primary key, which is the bad example here, then if I have New York and Adam Smith, every Adam Smith in New York, they would share the same record, right? So if another Adam Smith is born and I add another birthday, that would override the previous Adam Smith who was born, right? So that's so you want to have something in there that is unique. I think you could say it's debatable whether email is unique enough. I think you probably would have a social security ID or something like this, or a passport number or something in order to really ensure uniqueness. But for the purpose of this example, this is probably good enough, right? And this one is also a good example. This is really, where you have a user ID, right, which is unique to the user and not shared with anybody else. So that's enough. The difference here is that you do not have so much capability sorting your partition, right? So every user ID is basically its own partition. There's nothing else in there. So it depends on your use case how useful it is to just do that. But it's absolutely perfectly valid, and it's a good example, right? There's lots of examples you might want to set up something like that. And this one is not unique enough, right? So we think that's a bad example. It really depends on your data set, but in general, I would say that's not unique enough. Just think about all the people who share the same name in Mumbai or something like this, for example. Then the partition key is the identifier for the partition, right? And it's used out of a column from your data, right? So this is user data that basically determines the partition. And as I think Alex alluded to this earlier, so basically what happens with the partition key, it gets hashed and a token is generated from it or determined from it in a deterministic way, and that decides on which nodes or which nodes the data should be stored, right? So and this is totally deterministic, and it will always get back to the same node. But it uses your own data, so you don't have to do anything special in order to elevate a column to be a partition key, and it doesn't have to be any special characters or anything. It's just your own data. And again, this is a good example, right? So primary key is user ID. These are small partitions. This is also a good example. For example, if you think about YouTube videos, right? So we're storing all the comments together for one video ID. So basically, when we select the data by this video ID, we get all the comments back. So that's the idea. So we just get the whole partition back in one swoosh. Versus here, we think that could very likely be a bad example. And the bad example is mainly because this could grow quite unbounded, right? This could become eventually a very, very large partition. And this is an idea about, for example, an IoT device, or if you think about in your car, a telemetry device that stores temperature or speed or whatever, and then you record it every second. And you can imagine that if you let that run for a couple of years, that you would have a huge partition there, and that's something that you might want to avoid, right? So it depends a little bit. Everything depends on your use case and how much that they want to store, but that's what you have to think through a little
Exactly.
bit.
Always think of the use case, because table is perfectly great and partition key is defined perfectly good for some use case, will be a real disaster for another case. So there is no silver bullet. You have to think. Sorry.
Yeah, you have to think it through. No, absolutely. I think I also don't like to say this is a good example or a bad example, because it always depends on, I mean, like, for example, if I only have one user and everything goes in, that would also create an unbalanced cluster, right? So, I think not everything. You have to think it through, right? Right, now the important aspect of clustering columns. So they help you to add uniqueness, right? So in this case, we had the city, but then we give additional uniqueness by having the last name and the first name and the email, right? And but they also serve another purpose. They help you with ordering, and then it orders sort of like in the order of the clustering columns. So within the partition, we would first order everything by last name, and then within those smaller sort of partition pieces of last name, we then sort everything by first name, and then within that, everything by email, right? So that makes it very easy to retrieve sorted data. So you say, give me everybody, with the last name Smith in the city of Phoenix, right? And then you get them sorted by first name, for example. Or you give me every city and give me all the last names in the city of Phoenix, and then you get all the last names sorted by alphabetically, right? And you can decide whether you want to have it ascending or descending. So that's very useful in order, that you don't have to take an additional step to sort the data, and that's also how the data will be laid out on disk. So it really makes selecting the data very fast and very efficient, and it's a really good advantage of Cassandra. And that also answers the question that we always get to in these workshops. Is it not enough to just have city and email for uniqueness, right? It is, but it might not be so useful, right? Because your email addresses are unlikely to be meaningful names, right? So that you can sort them properly, right? So that it makes sense. So versus last names, it's much easier to find them, right? So if you want to... That's an example.
I would say it this way. If you don't want your users to be sorted by last name and first name, when just city as a partition key and email as a clustering column will form a great primary key. You sort you partition your users by city, and you ensure uniqueness with email clustering column, and that's perfectly fine. And it will work. The only issue here will be if you at some point would decide what you want to have them sorted by the last name, and you want to provide this user list in the alphabetical order, then there is a situation of there is no field basically in the primary key to sort them. So that's okay.
Or to look them up, right? If you then want to go and look up just by last name, if you don't have them in there, you wouldn't be able to just look it up, right? So I think again, it depends. You want to be clear, right, what you want to do with the data, and that will inform how your table will look and how your primary key will look, right? So again, as we covered, this one is not such a good example because I think there's a very high chance that this is not unique. This is good. And then here, this is a good example here. This is a bad example how you don't want to do it in a way. So when you have your video IDs in YouTube and the comment IDs, and depends how the comment IDs are structured, like with, for example, the unique IDs, then they're unlikely to be in a really good shape that you can sort them, right? So it doesn't really give you any good sorting order. So this one is a better one where you sort by timestamp. So you have your video ID and then you sort it by timestamp, and then you also retrieve the comment ID, and that's the uniqueness.
Exactly.
Okay? Good. So let's talk a little bit about partitioning, because I think, and this is where I think this is also very interesting for the administrators to understand, and all the discussions that you might want to have between developers and operators in order to get a really good database setup and a data model that works well for your database. There's a few, the partitioning is really important. And you have the power of partitioning when you create your table, right? By deciding on the primary key and the partition key. And there's some things that you should really, really practice. And we really would love you to practice this with Astra and with the setup that we have today, and continue practicing also after the workshop. So you want to avoid that. You want to partition in such a way that you can store all the things that you want to retrieve together, that you store them together. And you store them on the same nodes, so that if you do a select request, the database really has to go to only one node, but do only one disk read and get it all out. So it doesn't have to go to lots of different places in a database to assemble your answer. And that's going to be fast and it's going to be efficient. And so this is an example here, right? So where we look it up by video ID, and then we sort it by created, and then we also have the uniqueness from the comment ID. Versus if we wanted to sort it by, look it up by comment ID for one video, we would have to go to lots and lots of different places in order to retrieve all those comments, in order to assemble the view that we have per video. So to not have the video ID in here simply doesn't make any sense in this respect, right? We want to group it all for the video and then sort it in there and then display it as unique rows. So something that we will come back to this again, and it's so fundamental, and we really encourage you to practice this, right? Store it together how you want to get it out. And it requires that you know the questions that you might want to ask the database, right? So if I have the question, give me all the comments for a video, the video ID is absolutely key in order to store those comments together. The next rule, and this is really important, and this is something that typically only comes with time, right, and with use, right, with scale, is that you want to avoid really big partitions. So when you get started and you write your few tests, etc., you're not running into any problems with big partitions. But if you deploy and into production and it keeps running and running and running, and suddenly you have your data model choices that you made in the beginning lead to unwieldy partitions that make operations really hard, right? And suddenly sort of cause your database to grind, and find it hard to, clean up and repair and maintenance operations under the hood. So something that you really want to avoid. And as a rule of thumb, you sort of say, don't have more than 100,000 rows in a partition, right? And, it sounds like a lot. And, say 100,000 rows is probably equivalent, typically to 100 megabyte in a partition. That's sort of like the recommendation. I've worked in support for 3.5 years at DataStax, and I've seen partition much, much, much larger. I think the largest I've seen was a terabyte. It's definitely not something that you want to have.
Oh my God, 1 terabyte partition.
Absolutely. 1.07 terabytes.
Don't do it.
Yeah, that was the maximum. No, don't do it. Absolutely unwieldy, right? And the reason why we see them in support is because people come to us and say, it's not working, right? This is really... So this is a good rule of thumb. It's much easier to count rows than it is probably to assess fully the size of your partition. Just make sure that you don't exceed sort of like 100,000 rows. And we have this example here. We've discussed that this is quite a good example. And here, this is a bad example because we think, if you put all the users of India into one partition and all the users of Germany and all the users of Iceland, you have already 3 very differently sized partitions, right? So, and not only have you got one really large one from India, you also have quite unbalanced nodes then in this way. And so, you will have some nodes that use a lot more data storage than others. And so it's just, and nodes that are hit much more by read requests and write requests. And so it's just not good to have this kind of imbalance in your cluster. So you want to think about that. You had a comment, Alex?
Yes, I think I want to explain why you should avoid big partitions. There are 2 points of view, operations team and developers team. And this workshop is for developers, so I will explain it for developers. If you do your partitions too big, there will be angry people coming from operations with some heavy tools, and they will be very unhappy about you. And they will be very angry to you. So that's why you don't do too big partitions. And from operations point of view, to explain why exactly it happens like that, that's not maintenance course and operations course, so I will not do a too much deep dive. But partition, as we say, is something what store it together, store it as a single file or within a single file. As long as you have your partition of the size of 1 terabyte, that's going to be one file of 1 terabyte. And can you imagine faces of the database administrators when they will find out that? They will be not happy. And your database will be not happy. And maintenance operations will be extremely complex or even maybe impossible. Well, of course, there are ways to solve that, but still, you do want to avoid big partitions.
I think we got some questions here. So I think David just pinged that if you have a lot of columns in your data, that should be fine, right? So that's not a problem. I've seen columns, 200 columns per table. That's all right. You might not, I don't think you want to roll them all into the primary key, because then you would have to specify them all when you select or write anything. But otherwise, there's really not a restriction on how many columns you might want to have. So that's I don't see a red flag there. It might just be your data model that requires that. Right?
Yep. Regarding oh, sorry, are you done, or I don't want to interrupt you, sorry.
No, you can go ahead, please.
Yep. Regarding the column limitation in Astra, there are some tricks you may need to learn about user-defined types and list sets, maps. We explain them later today. I think we do.
I don't think so. We don't have much about lists and maps today. So I think, what is the column restriction, Astra? So
there is a column restriction in Astra. Table cannot have more than 50 columns at the moment. But well, that's an Apache Cassandra workshop. So let us move on at this point.
Yeah, okay. I didn't know that this was that we have some guardrails in there. So that's okay. So next, actually, I think David sort of just put a question in about wide partitions. That's often also a term for large partitions, right? So huge partitions. So I think it depends. It depends on your concept of row, whether wide rows and wide. That was the sort of like in the previous terminology was sort of like the name of a wide partition, of a large partition, and so it's not necessarily the number of columns that cause your partition to grow. It's the number of associated rows with that partition that make the partition big.
Definitely.
Right.
So I would step.
So
go on.
Yeah, go ahead.
Okay, I would step in regarding this slide and this example, because this one is an example from real life, and I know what happened and how it happened, and that's why we add this slide, these rules of a good partition set. We speak not only avoid big, but also avoid constantly growing partitions. We speak about a huge IoT infrastructure with a lot of sensors reporting their state, like humidity, temperature, I don't know, network output, whatever you can imagine regarding IoT or network communication, and so on. And we don't have to store so many of the different data for this use case. We need to store sensor ID, which reported its state. We have to store the timestamp, when it happened, and we have to store the value. Was it a float or integer? Doesn't really even matter. And it was the story with one of our partners and friends who designed the table like this: primary key, partition keys to be sensor ID, and reported that as to be clustering column to ensure sorting order and to ensure uniqueness. And in the beginning, everything was great with this partition, with this design. But after some months, it all started to work like in the not the best way and not the best approach. What's the problem? Very easy, as you can imagine. First few months, partitions weren't too big, but as every sensor reports something every 10 seconds, then you are going to have very huge partitions over time. And then we find out what design of a sensor ID and reported timestamp is not the great anymore. And partitions are too big. So how to solve this problem? Bettina, would you please switch it to the next slide? Short answer is bucketing. The main trick is you may have more than one column, more than one field in the partition key. And then they both together will be used to generate new partition. And our suggestion was to use buckets, and then partition key would be first part sensor ID, but second part month and year. Some people asked like, can't we use just use a date of the occurrence to bucket the data? This approach with sensor ID and date would work, but it also brings some downside. Yes, it will make one-day buckets. As soon as bucket is full, day is over, we switch to a new bucket and therefore create a new partition, and that's perfectly fine. The problem is, when you query for the data, you must always specify full partition key. Because if you do not specify full partition key or specify only part, what happens next? Cassandra has to somehow query one of the servers responsible for this table to get this data. And as long as you have 3 servers, 5 servers, it's maybe not so big deal. But as long as you have 100 of servers in your cluster, 1000 of servers in your cluster, which particular server you are going to ask? No idea, therefore you have to ask all of them. It's called a full cluster scan, and that's a very strong anti-pattern to avoid. And therefore, if you are going to query data on sensor ID and date of the occurrence, you will have to specify always sensor ID 1 to 3 and 1st December, 2nd December, 3rd December, 4th December, 5th December, and so on. There are no inequalities for primary keys. And that's obviously not going to be convenient to use this table. So we suggest to use as a bucket in this particular example, month year. Like today is 1st of October, year 2020. Therefore, month year, is it an integer or string, that doesn't matter, will be 102020. So 10 month number 10 of year 2020. And November will be 11 2020, December 12 2020, and so on. This way you create bucket on every new month coming for every new sensor. But when you are going to load data and you want to watch the temperature in your room for the last month, you are still doing one simple query, sensor ID 1 to 3, month year, 10 2020, boom, it's done. That's how bucketing works.
Exactly, and we see that, for example, other applications are billing, right? For example, monthly billing. There's a lot of use cases for Cassandra where this is done this way. So you can retrieve everything for the month in one swoop, and you do not have to go to 30 different partitions in order to build up that billing view, right, for the month. Okay, wonderful. Thanks very much, Alex. So last rule is avoid a hot partition, right? So basically avoid that one partition gets extraordinarily often hit and read and selected, because that basically just makes certain nodes work much harder than others in your database. So it sort of like ties a little bit in with the big partitions, and because hot partitions often also lead to big partitions.
Yep.
Right. So this is
partition maybe not so big.
And again,
sorry, please go on.
No, that's
okay.
It can be related, but it doesn't.
Yeah.
Right?
So partition may be not so big by itself, but it's if it's very active and people read something where all the time. So take a look. You may have as much servers in your cluster as you want to. Let's say you're working with a single data center to make it easier to explain. And you have 1000 servers in your data center. And that's pretty powerful thing. It's going like everything should be easy. And then you have a situation like that. Take a look. You are e-commerce company selling something in Europe, for example. So we have a lot of small countries. And you did your partitions for your users by country, like the last example. Country as a partition key, user ID as the user ID, clustering column. And as long as you work with Europe, so Belgium, or I don't know, whatever, a lot of small, Luxembourg, a lot of small countries, it's perfectly fine and it will work. But when, let's say, you go to Asia, you start to sell in China, in India, and you are very successful, and there are so much people, so, and congratulations, so now you are very on a very cash flow for the sales in these countries, like congrats. But what happens next? You have two extremely active partitions, India and China, let's say. And what happens next? Don't forget, replication factor 3 or 5. Therefore, your partition will be stored on 3 or 5 servers. Well, you can set different value, but it still should be something reasonable. So usually it's 3, 5. And you have 3 servers handling this kind of data, and you have hot partition, and people are buying something, doing something all the time. And what happens next? You have 1,000 servers, 3 of them are replica servers, 3 replica nodes for this partition, and they are busy all the time. They are overloaded. They are hardly handling amount of operations, and 997 servers are basically idling. That's what call it hot partition.
Do nothing. Yeah, so you have to think it through, right? And I think we encourage you to think it through with time, right? With scale. How would it develop over time, right? In order to sort of like model your data and see how it would behave over time. Everything works absolutely fine in the beginning on a small scale. So you want to think about how would it behave with a significant scale, and so that you don't become a victim of your own success later with your data model. Good. But we've done so much talking, and I definitely want to get back to hands-on. And we are at this point. So we want to create some tables ourselves, and we do some example tables today. And we will insert some data, etc. But we want you to actually practice with this and try it out on your own, also after the workshop. So let's see whether we were here. Good. So let's go back into our SQL console and start working with it. That's still there. That's wonderful. So make some room here. Good. So in the GitHub repo, so we want to go to create a table. That's the second exercise step in here. So if you've logged out of your data of your console, you might have to refresh, etc., and see that you can back in. And again, just observe it takes about a few seconds before the password prompt comes, and then you might not see the password when you type it in. And then let's have a look a little bit how we actually work with key spaces and tables in there. So as I said earlier, you can do describe. You can also do a shortcut key spaces, right? And then you see we have one user key space. That's the one that we set up. And if you want to use that, we just do killer video, and I use just the autocomplete by hitting tab. And now I'm in the killer video key space. And I can see this in the prompt, right? It's added here, I'm in that key space. That just saves me always adding specifically which key space I want to work with. So it makes it a little bit easier to type things and to create something in there. It's not essential that you do that though. So now we can have a look what's in this key space by just typing describe tables. And it's empty. We have no tables in there. Right. Again, if you wanted to just do desk tables, that's also fine, right? As a shortcut. So there's nothing in there. So make some room. Okay, so we've given you everything in there to copy there basically. So this is the first command that we want to execute, step 2C. We want to create our infamous by now users by city table, right? So this is the one that we've been discussing the whole time. So we can just take this, copy it, and paste it in, and hit enter. And you want to make sure that you always end with a semicolon, because if you don't do that, it will just continue to ask you with these 3 dots, what else you want to type, what else you want to type. So just terminate your command with the semicolon and hit enter. and then you should be there. Now if we do our describe table, so we can use the up arrows to get back to your previous commands that you put in there. So now if I do describe tables, I can see here that I have a users by city. And I can also be quite explicit and say describe table users by city. Again, I use the autocomplete because I'm with the tab, because I'm really lazy. Terminate with the semicolon. And now it shows me the table and shows me a lot of additional things. These are all the defaults that have been sort of created for this table. These are called table options. And in most cases, you really do not need to deal with them, right? So there might be some advanced cases that you want to change something if you're really, you know, an advanced user. But for now, it's absolutely fine to stick with the defaults. And you probably don't have, you might be restricted changing those anyway in Astra, in the free tier. So there we are. We have our users by city. And you see here now that we have actually a specified clustering order, right? We have the last name ascending, the first name ascending, and the email ascending. That is the default order, ascending. We could also create our table with different clustering orders, right? So if we do here, if we go back and create a table again, let me just create a second one here. Perhaps here, just start this off here with create a table user by city 2, right? And then I put these additional comments in there. So and now I need to specify my primary key. And this time I want to have a slightly different order. I want to do that. So I want to say here, I think I can just put that in here. I hope I didn't. Oh no, probably did a little bit too much experimentation here, so I probably would need to look up the exact syntax.
There is one more, there is too much closing parentheses in the very end.
Is there? Are you sure?
No, but
I
looks
don't
good.
think so.
Sorry.
No, I think I just need to specify something exactly how to do it. I think, yeah, so I think I'll look it up in a moment. I'm feeling exposed. I know exactly how to do it because it gave me this one here, the clustering order. I want to do that here. Skip this, please. Okay, so let's do that. Let's do this again here. I do just this one. Sorry guys. I think I'm making a fuss here for something silly. So clear this. So by user city 2, and I want to add all my columns, and I'm doing this without terminating this like this, right? And then I put the with clustering order. Oh, I'm probably getting into a fluster here again. Oh yeah, I think I get here with clustering order. So here, this is the one. And now I want to change it to descending. Yeah. And now I finish this with my. Oh, not again. Okay. Oh yes, and now I forgot one. Probably here. Oh, okay. That's the demo effect. I shouldn't have done it. I look it up and I updated it later in the question. Sorry about that. Okay, but anyway, we have a table. Let's have a look at the tables. So, and we have the users by city. And if you follow the example, you should get to exactly the same point. I apologize. Okay, give us a thumbs up when you're there. And also I encourage you to experiment with additional tables. So you can put different columns in, you can experiment a little bit with how many clustering columns you put in there. And because later on when you put some data in there, it will be different how you put it out. How is it looking for thumbs up?
Let's take a look, but I think we have to give 1 more minute. Yes, okay, but we have people following and creating them, which is great.
Excellent, brilliant. Cool. Okay, so this is basically how you create tables. So we will only, in this round of exercise, we only create one. Actually, we could actually create the additional tables that we use in the next. Oh, here is this, the clustering order by, here, there you go, comment ID descending. So I probably did something, comment ID descending. I probably did some mess up with the buckets here. So if you want to, you can also use the step 3a. So by creating these tables and create these additional tables in your database. This is from a slightly different data model where we use videos and comments. And we come into this in a moment, but we can create the tables now so that you have them in your database. So you can put them in there. And then again, if you do a describe tables, we now have 3 tables: comments by video, comments by user, and users by city. Good. And in the meantime, I just have a quick look at the Slido. What we have? Oh, created by table. Awesome. Which place the data store in Cassandra platform? I'm not quite sure what that means. Cassandra stores obviously data on disk eventually in dedicated data directories, in dedicated files, right? So these are called SS tables. I'm not sure whether that answers the question. So this is just people helping each other out. That's wonderful here. That looks good. A backup solution can be connected to data stacks to backup the database. Absolutely. Yeah, you can definitely backup your database.
Can a backup solution be connected to data stacks Astra to backup the database created there? Then answer is there is no need, because Astra is a managed solution, so we are backing up data for you.
Yeah, exactly.
If you mean
we're
Astra.
backing up every 6 hours in Astra. So you do not have to care about the backup because it's managed as a service for you. But in general, yeah, absolutely. Cassandra can be backed up like most other databases, and there are a couple of backup solutions there. And you also have just basic command line tools to do that. Okay. After creating a new key space, do I need to relog into SQL console? And you're not able to find, yeah, you probably have to log in again into the console if you left it open while you created the database. The additional key space, if you're not able to find it, it might not have been created yet, right? So you want to check again. And then can we deploy machine learning algorithms trained on the cloud in Cassandra?
I would say it this way. So by itself, Cassandra is the database. And if you want to store it on Cassandra for machine learning, it's a very often use case, because usually you do machine learning on big data, and Cassandra is big data ready. So it happens all the time. And obviously you can use data from Cassandra for your machine learning. Typical scenario, you have Apache Spark running, and with DataStax Spark Cassandra connector, which is one open source, I believe. You connect your Spark to Cassandra and do whatever machine learning supported by Spark. So basically everything you need with that. You also can connect with Python and use all the Python machine learning libraries. So answer is yes, but Apache Cassandra per se, as it is the place to store data and answer your responses very quickly. So that's an OLTP database to work with real production workloads.
Okay, so I think we want to move on with the presentation. If we have enough time at the end, because we still want to go through another module of theory, a bit about how to do data modeling, and Alex wants to present that. And I hope he doesn't talk too much because we still want to have a little bit of time for the next hands-on, and then we come back to questions after that. And we also do our Menti quiz. We mustn't forget about that.
Yeah, absolutely.
Right? So we have about 25 minutes left. Let's keep those questions to the end, and if there's too many questions in the end, we just answer them in Discord. Okay, so Alex, it's your favorite subject.
Oh yes,
the art of data modeling.
Finally. Good. So
you want to take over again?
Yeah, definitely. Give me a second. Okay.
Studio.
So art of data modeling. So take a look. This one is really important. Thing is, Cassandra provides you a great set of features like highest performance, disaster tolerance, geographical distribution, and so on and so forth. And that's all great. VFastra is also even easy, but if you do your data model wrong, you can ruin everything. Do your data model wrong, introduce hot partitions, and as I tell you before, you may have 1000 servers, but still you will have some heavy performance issues with the data model done wrong, and so on and so forth. So if you want to done things wrong with Cassandra, data model done wrong is the best or easiest way to achieve this goal. If you are like me, want your database to work smooth and have no problems in production, then you are going to pay attention to everything what we will say right now. And let us start. So, easiest way to explain data model creation done correct for Cassandra is to start with something what is familiar to all of us, data modeling for traditional relational databases. I bet every one of you have experience with some relational databases, doesn't matter if it's MySQL, PostgreSQL, Oracle, or whatever you are using. And when we think of creation applications with relational databases, we first start with the data. So first we start to analyze the raw data we are going to work with. We think of its properties, relations, and how they work with each other. And then we identify entities based on that. For example, if you work with, I don't know, client relationship management system, you will think of the clients and how they relate to each other, which managers from your companies and which teams works with different clients, and so on. So you anyway going to have some entities. Those entities will have some properties, and those entities will relate somehow. For example, an engineer is going to work in some engineering department, and boom, we have a relation. And this engineer name is, I don't know, Samantha. Therefore, it has property, name, Samantha, and relation to engineering department. Very clear. Based on these entities identified by us, we start to design tables using normalization and foreign keys. What does that normalization means? I hope you have the basic understanding of the normalization. If you don't, then most probably you have to learn a little bit on that. Normalization and denormalization are very important techniques. But in the very short, normalization is the way to avoid any data duplication in your tables. And if you have engineer Samantha working in engineering department, we speak about two entities. One is employee and one is a department. We are going to have two tables, and there will be nothing like engineering in the list of employees for Samantha. Only a foreign key which specifies in which department she works. Very simple as that. You do not duplicate data. And then when you are going to load this data and to show the list of your employees, you are going to do select all from employees, left join department, where employee ID is 5, I don't know, or whatever you are using. So we speak about join. In the relational database world, join is the way when you combine normalized tables to have denormalized answer. So you have all your data from normalized tables within still one single answer, and you join tables. And that's all great, especially on write time. So when you add information about new employee, you do basically one simple insert. You add only employee name, foreign key ID to the department list, and it's done. So you write information only once. But it also brings you one single downside. When you read information, you're going to do a join, and joins are pretty heavy actually. Developers very often don't think of that, but joins is not a simple thing, and join is double heavy thing when you start to have more and more data. At some point, your table will not fit into the memory of a server, and when your read queries will be very, very, very slow. To speed it up, we use denormalization, and that's a very often case for any high-loaded projects, even using relational databases. When you start to denormalize data and therefore duplicate data, and you have word engineering in two different tables. You will have word engineering in the departments list, but you will also have word engineering in the employees list. I mean, word as a string. Why? To avoid join on the read. So this way, denormalization, you have to write two times. If you are like renaming department, for example, you do a change, you write it to both employees and departments. But when you do a read, you avoid a join, and when your reads are faster. And that's a technique also very used in Cassandra. But okay, let's get back to relational data modeling. We go from data to model to application. Analyze data, build models, create application using these models. Okay, with NoSQL data modeling, it goes exactly opposite direction. We first start to think of the application workflows and how it's going to work, or I would better say let's start think of people. We are thinking about software and hardware too much, but we always forget about the people, but that's all for people. So let's start to think of our clients, users, or whoever, whatever people will use this application. Let's think of them. And we analyze their user behavior and what are they going to do with our application, which problems we are going to solve with our application. That's what really matters. And we analyze user behavior. So what exactly people are going to do with the application. We do it to identify workflows. So we do not identify entity, well, we do identify, of course, entities and their properties, but the new big thing, we identify workflows, their dependencies, and their needs. Based on these workflows we identify, we do it in a minute in details. We define queries which will fulfill those workflows. I mean real database queries. And then knowing the queries we are going to run, based on the queries, we design tables, heavily using denormalization. In Cassandra, query is the queen, query is everything. And only knowing, understanding your query very well, you can design your data model well. And when we use special tool called batch, when inserting or updating denormalized data of multiple tables, to ensure what data was delivered to all kinds of the tables, we are going to update. So don't forget, normalization makes simple write and better data integrity, but it makes slow read and complex queries. With denormalization, we go for quick read because we want our customers to not wait. We want to dispatch them answer within milliseconds, very ready, very quickly, every moment, even with big data system. And yes, we have to take care of multiple writes and take care of the manual integrity. So that's the price to pay for the highest possible response time, or for the lowest, best possible response time for our customers. We have to take care more about the data integrity, as there are no more foreign keys. We developers have to take care of that. But you know what? We are getting money for that, so I'm very fine. I can take care of the data integrity. And multiple writes, well as we are doing them asynchronously, and we have to do it asynchronously, and batch is doing that asynchronously, we are very fine with that thing. Now, let's walk through the designing process step by step. Again,
you have 2 minutes to do that.
yeah, we are very, very low on time, so I will be very quickly. There are 2 things to consider. Conceptual data model, that's about entities and relationships. And application workflow, I told you, so queries in the final end. And we are going to work on a very simple example, comments for video, comments done by user. Let's think of a YouTube or our very own killer video, but easier to get an example of YouTube. So people may comment video, mostly some of you may be doing right now, I believe. And user has ID, email, and some other properties. And video has ID, title, description, and so other properties. And comment has timestamp and comment text by itself. And one user may do many comments for video, but one comment relates to only one and one only video, of course. So that's the conceptual data model. Entities, properties, relations. And then second thing, application workflow. We speak about the comments for the videos on YouTube. And we have 2 main use cases. User opens a video page. We have to show comments latest first, and we have to find comments related to target video using its identifier, which we have. And second use case is user opens a profile. So we want to find comments related to target user using its identifier, get most recent first. And those are 2 different use cases, because don't forget about the main limitation we have to think. In order to query the data, you need to know partition key. And partition key is something what's the video ID going to be, or user ID, as you will see in a moment. Therefore, we cannot retrieve comments for a user, single user, given the no video ID. It just will be not enough. So, first query we are starting to think, we are going to find comments posted for a user with a known ID, most recent first. And we think of the comments by user. And the second one will be find comments for a video with a known ID, most recent first. And we already start to think of comments by video, mapping those 2 fields together. So conceptual data model and application workflow. When finally we have some query and we see how those query works. Select everything, don't use select everything, but for the demo example that will be fine, from comments by user with user ID, and the same for video. Next step will be for us to organize logical data model, and we think of comments by user, comments by video. Tables are very similar, but they have user ID, creation date, comment ID, video ID, and comment, and the same for comments by video, but in a little bit different order, because video ID will be a partition key. Once again, we need to have 2 tables here with a denormalization, because in one case we are going to query by user, by author, and in the second case we are going to query by video. And we do need to have proper partition key, otherwise we cannot query data on them properly. Now, here comes one really nice optimization I like so much, one of the many optimizations I like so much in Cassandra. Here we have 5 properties per table because it's a logical data model. But on the physical data model, it's already a little bit shorter. Why? What happens? There is a special data type in Cassandra called time UUID. It's kinda united together, merged together data type, which is a half universal unique IDs and half date timestamp. So time UUID is something what behaves like UUID, a long number, but it also sortable by time, and you can extract time out of that, and that's a very cool and convenient way. In the final result, we have comments by user with user ID, comment ID, which also includes time, and video ID and comment. And mostly the same in comments by video, except of the video ID is going to be the partition key. Key means partition key, and C means clustering column with a sorting order specified by arrow. And finally, we have our table creation language definition. So we go with create table, if not exist command by user. All our properties specified. Partition key will be user ID. Clustering column will be command ID, with clustering order by command ID descending, because command ID is time UUID. And mostly the same for commands by video. And now we have to...
And you want the most recent first, right?
Yeah.
So that's...
Yeah, exactly. And now we are going
to try that out.
Yes. So
Julia, let me just go back
give me
to
a second.
Astra.
I will switch to your screen. So, Bettina, your screen is live.
Perfect. So hopefully you see the console again, so the Astra console. And exactly, these were the tables that we just created in the last step, because we were in the process of creating tables. I thought we might as well just do that. And let's focus a little bit on the entry of the data. And I saw in the chat that a few people have already completed everything, but I want to make sure that we focus on some of the things that are important here. So let's insert data into these tables. Here's a simple insert statement here. And I want to highlight that we use here, for example, a function. That's the now function. And the now is a server-side function that's executed on the Cassandra server that calculates for you the time UUID, right? Because it's actually pretty hard otherwise to sort of like create it, right? The DataSax drivers also give you this ability that you can generate it on the client before you put the data in. But you will need a utility like this that creates the time UUIDs for you. In this case, we also have the UUID, which uses the values for the UUID value. And again, we have helper functions to create them for you. In this case, we're hard coding them, so we find it much easier to look them up again for this example. But in real life, you would use a function like UUID brackets, which would generate for you the unique UUID here, right? So that's something that I really wanted to highlight. So let's just insert this data here. And so this is just one insert here into comments by video. And again, I saw some people commenting that the copy and paste didn't work. So I haven't experienced that. I think if that persists, you probably want to let us know, and we want to look into this. But that shouldn't work for you. But here, basically, I just copy some additional comments here, then some additional inserts just from here with copy and paste, and put that into the console with Control V. Yeah, I'm using keyboard shortcuts to copy. I think you might have to do that. And then the last one, that's from a different user here. Right. Okay, so we have some sample data. And yeah, I would encourage you to practice, to do something with these different functions, so sort of see whether you can get some additional data, and just practice putting data in. So, and then we can just select star from comments by video and see what we have in our, yeah, that's the data that we just entered, right? And you see some of those were generated with now, so these are the kind of time you can see time UUID has always in the third block, it has a 1 in the beginning. Then you know it's a time UUID. This is a normal UUID, so in the third, oh, it's also has a, no, this is
coincidence.
Oh yeah, so that's a coincidence. Yeah, exactly. I think it always has a, yeah, the 11 EB or something that is specifying the time UUID. And we use this throughout in Cassandra. It's a very, very useful concept, because we have so many cases where we want to express uniqueness, and we also have so many cases where we want to express timestamps, and to be able to combine them together is a really useful concept. Okay, so let's have a look at the different data. So this is, I don't think there's anything in there for comments by user. Oh yeah, we did them in here. So comments by video. I don't think we insert, here, I forgot all about these ones. Okay, so put something in for comments by user. And copy them. And then again, star by user. And so we have, the comments here for the same video ID. And in this case, so we have the user IDs here, and again, we hard-coded them, so we find it easier to look them up, right? So now we can look them up for a given video, for example, or for a given user, for example, here, where the user ID is this hard-coded 1111, so if you find it much easier to make sure. Here it is. So we are now looking up directly by the partition key, right? So this gives us everything for the partition key. If you wanted to look it up by the partition key and the comment ID, then we have to put both in order to retrieve the value. And something that you cannot do, and it's worth pointing that out, we cannot look anything up by a different data column. That's not part of the key, right? So for example, if I wanted to look up here where I'm using this comment, so select everything from comments by user, where the comment equals, and then I put my comment in there, I should get an error, right? So this is an invalid request, and it says here, cannot execute this query as it might involve data filtering and thus may have unpredictable performance, right? So it gives you actually the workaround here, but we tell you don't use that. Basically, you can explicitly say allow filtering, which means allow reading every single row in this table and filter out the value that, for this comment. So this is, for a large table, you can see that this is incredibly inefficient, and you would have to go to every node and every partition and look through this. So this is not recommended. So this is, again, something that you want to, you want to really know what data you want to get out and how you want to select it. That informs your table design, so that you don't run into these kind of restrictions. Okay, so then when we've read them all, so you can select them all by comments. That's also, you can retrieve them all. That's probably, again, for a very large table, you don't want to retrieve everything. Right, so it's something that obviously works for these little examples, but this is basically tell me everything for the table, and it's not something that you want to do very much. And okay, and now let's update some. So let's use this one here. Insert the specific comment, so we can then put like into comments by video. For the video ID, we just like, oh my God, that guy Patrick is such a geek. So, and we can override this. First of all, let's look at it, select star from comments by video. There we have, oh my God, that Patrick is such a geek. And then we can override it. We can, with an update, insert, or we can just use another insert, so we can do both of them. So this one is an update statement. So in this case, oh my God, that guy Patrick is on fleek. We just changed it slightly, and if we select it again from the whole table, there we go, we see that has been updated. But we can also just do this as an insert. So we could just override where we say insert into this table with the same video ID and the same comment ID, and everything that we then put into the comment and the user ID columns would override this record, right? Because of the, I don't want to mess with the demo gods, skipping that step of reforming. But yeah, so that's basically how you insert data, how you update data. And the last thing that we want to do is show you how to delete data. So again, you would be very specific how you select the data. So you need to use the video ID and the comment ID in order to delete it. So, and then if we select it again, oops. Oh, I made a mess here now, so never mind. So if we select it all again, there we are. Now we've deleted that last just comment. Okay. So I would really like you to play with it. Yeah, play around with it, put some more data in, delete it, sort of like see how you run into some errors as well. I think that's always very useful to understand what sort of creates an error and what kind of error, and just play with it. So you can also delete an entire partition. I think we have here some with the same partition. This is the one. So we're going to say delete, let's see, comments by video, where video ID is it ID equals, and then you can just put this in the entire partition, and that should delete 2 rows in this case. There you go, and if you can do select here, now we only have 1 row left. So again, so you have this kind of granularity. You know, you can do things that affects the whole partition, and then you can do things that affects the whole, just the primary key. But you cannot do things that just where you just select by a data column. You always have to specify the parts of the primary key, the partition key, or the full primary key to do something. Okay, so I think we want to go to Menti before it's too late.
Definitely.
So absolutely, and hopefully we still have everybody with us. And let's just we go back to Menti. Let me know if you can see this. So yeah, I think I see some people still coming in there. Let me know whether you can see this fine. And okay, and then let's see whether I've got to the next slide. Okay, that's wonderful. Quiz time, perfect. Cool. Okay, so back to Menti 608855.6. That's the Menti code. And just indicate you want to play. And then we have 5 questions. So now you really want to look at your phone. You want to answer very fast, because the fastest they win, you know, the top 3 in the leaderboard will win the prizes. And it's the correct answer is also the time, is how quickly you answer. So just be as fast as you can. Okay. How much should I wait for? I've got 20. I can see 28 in there. What do you think, Alex? 31?
I think maybe give them a few more seconds. We have 150 viewers at this moment, so I want to have at least 50 people jump in.
Yeah, that's true, actually. Yeah, you want to win some prizes. So they're nice things. That's the data stack expanded things. Okay. Cool. Okay, I give it.
There is a
while we are the answer to everything.
Yeah, while we are waiting, there is a statement in the chat. I have to disagree. Cassandra supposed to be data storage alternative to tools like Hadoop and not an alternative to TXNDB. I guess TXNDB is meant to be transactions database, and well, I thought, no, not sure. Well, first of all, Cassandra is not the competitor to Hadoop because they work in a very different manner. So Cassandra is, once again, and I say it in the very beginning, Cassandra is the perfect database when you have high load, when you have a lot of data, and when you want your answers to be done within milliseconds. And Cassandra has some limitations on the search and analytical queries. So if you want to have complicated search over data storage in Cassandra, you mostly probably want to have Solr alongside to Cassandra, or DataStax Enterprise, which does it in mostly the same way. Or if you want to have some strong analytics over data in Cassandra, Cassandra is perfectly integrated with Apache Spark. Yes. So okay, that's what I would say.
Let's get started.
Yeah, let's get started.
We've got enough people for quiz. Perfect. Right, answer first to get more points. Really, and so what is Astra? Look at your phone. And is it a gateway to the stars, a local in-memory version of Cassandra, a development tool, or it is Cassandra as a service in the cloud? And Okay, perfect. Most people got it right. Wonderful. Very good. I mean, you can say it's also a development tool, but yeah, it's definitely a fully functional hosted Cassandra in the cloud. So what have we got here? We've got Broccolo on the first. Nice, very fastest. Congratulations, and Anuj, and I think what happened to Vamshi? I don't know why it's crossed out there.
No idea.
Yeah, I don't know. Never seen that. Next question. So 2 of 5. So what have we got here? What type is used to store both an ID and a timestamp? Is it timestamp ID, all the things in one ID, time UUID, or time ID?
We discussed it not so long time ago, so you have to remember.
Yes, very good. Time UUID, absolutely, yeah. Not a timestamp ID. Sorry if we sort of like were a bit tricky here. Yeah, time UUID is the right answer. Well done. And it's very, very useful and very frequently used. So, okay, how does the leaderboard look? Broccolo, you're doing fine. Oh, Vamshi is no longer crossed out. That's amazing. And
Good.
okay, so Jakob has joined the
And
leaderboard.
Magda
Well
was
done.
fastest.
Magda, I see
Yeah.
you, Magda. That's a comment. That's a name we've had before in the workshops. Welcome back. Okay, next question. What is the next one? What is a primary key? It's the same as the partition key. It uniquely identifies a row. It's a column in the partition key. It's the main house key. What is the primary key?
Don't forget, watch to your phone. YouTube will have a couple of seconds delay. So if you want to be quick, you have to watch your phone.
Perfect. Actually, yeah, it's absolutely right. Uniquely identifies a row. It's actually not a column in the partition key. It's the other way around. The partition key is a column in the primary key. So the primary key has everything, right? It has the partition key and the clustering columns in there. So, and it can be the same as the partition key, but it doesn't have to be, right? So in many, many cases, it is not the same. So this is the right answer. Uniquely identifies a row. Well done. And let's see how our champions are doing. Magda, look, you've moved up to 3rd place. That looks great. No, I'm not used enough to reading these ones. Magda, I root for you. Okay, so Broccolo, Anuj, and Vamshi. Okay, well done. You're really fast. You're much faster than I can ever be. That's perfect. And now, what's the next question? What is the partition key? I think I might just have helped you with my answers here. It's a designated field in your table structure to partition data. It's a consecutive number applied to each new record. The key to partitioning this reality from the next. An optional table field for optional partitioning. These are all very long answers.
Yep.
Let's see who gets those. Very good.
Take a look. It looks like we did our job great today. It looks like we did our job great today because most of attendees answered correctly.
I think this is funny that we had 8 people here. This is cool. Cool. So let's see how it goes. Let's see.
Okay.
Oh, Magda, you're almost there. And we had a change. Look, Balaji is the fastest. Oh, it was my mouse. There you go. I'm sorry. It was my mouse that caused the strike through.
That's weird.
Yeah, that's interesting.
Okay.
That's weird. Yeah, why would I do that? Yeah. Okay, well done. So, okay, last chance, last question. And what flow is used to create data models in Cassandra?
This one is tricky one. Be careful. Watch your steps.
Yeah, be careful. Remember what Alex said, right? This is Alex. So, is it data leads to models, leads to application, create data models, models leads to application to data, or application leads to models, leads to data? I see.
Yeah.
Oh, we had this yesterday as well.
Yes.
We sort of thought we should change the question. Yeah, it's a tricky one. So this is really the NoSQL view, right? You start from your application, you think about the user needs and the query needs, and that translates into models, and that translates into the data.
So,
Right, okay.
application models data, or I say people models, people behavior models data. And data model application is traditional for relational databases, not for Cassandra.
So I'm really sorry if this called out a few people, because we don't actually want to make them too difficult, these
we
questions.
have to rework this one.
Yeah, we have to rework this one. But, you know, it's only a game. But well done, Pokolo, Anush, and Balaji, well done. So if you identify yourself to Jack Fryer, so we can get all your details, and he will sort out sending the Slack to you. So he's got all the information there. Good. So while we still have your attention very quickly on the Menti, we would like you to quickly do a free-form survey for us, what we should improve for the future. And you can say anything, absolutely fine. Don't hold back. Be very happy to hear your feedback. Oh, it's so nice always when it starts. Oh, I like it. We're always going over time. When Alex and I, especially together, then we're going over time. Okay. Good. Visual appearance. See what we should do better there.
I'm not sure what exactly that means.
Yeah.
More time.
If you just put another.
More time and content should help more. Well, we can make this workshop many hours for you. It's going to be hard, but we will have a longer series getting much more in deep. So subscribe for us in Eventbrite and YouTube.
Yeah. So next week we're gonna do connecting to Astra with Python and Node.js, right, on your own, from Gitpod or from your local machine. So next week that's on the schedule. And see what else we had here. Right. Okay. So a lot of people want to get the voucher, right? So this is also something that we really need to address. So this time, I think, Jack, are you going to post the voucher form, etc., in the chats and in Discord? And we want you to show us that you're using Astra in order to get the voucher. And we have actually. We would like you to show your use and everything that you're doing with Astra in a little example or an example app, something that you do there. And if you could create a repo and give us the link to the repo in the voucher form to show us what you've done with it, that would be wonderful. So what we thought, if you find it hard to get started, we did this yesterday, and a lot of people just cloned this repo, which is perhaps not so useful for us. So we created a different template if you want to need a template repo and want to use it. So we're going to put the links into Discord, into the chat as well. So something along those lines, it's something that we would expect, to show us what you're doing, create some new tables, put your own data in, show us your queries, how you retrieve the data from with SQL, and show us some screenshots. Think a little bit about the data model, explain the use case and what it could be used for. Just get creative with Astra and let us know. Share your creativity. That would be wonderful.
Yep. So there are a few questions on chat. I will walk through them very quickly. For how long the form is open? Form should be open, I believe, for a couple of days. Maybe Jack will fix me. I don't remember exactly. Should we have to fill the form for a workshop? Yes, exactly. Form link was sent by Cedric already. Do we need to fork it? Obviously, you are going to make some changes into this sample code. So obviously you are going to fork it, as you don't have permissions to Bettina's one.
Yeah, don't file issues.
Yeah, but that's important point. So that's getting started. So if you want to create a powerful application using Astra, okay, it's great. We very appreciate that, but that's fine also if you do some not really big one. So the idea not to spend weeks of your works on that. That's something doable within a couple of hours, seriously.
Yeah. No, exactly. But if you want to create an app, that would be absolutely amazing, right? So okay. Yeah, so we don't want to stop you there.
My favorite. Oh, but, sorry, I was too fast.
No, you go ahead. Yep.
That's fine. And where can we get the invite for the next Cassandra event? That's my favorite question. Astra Celestia asks where can we get invite for the next Cassandra event. So our main place to be. Could you maybe open the Eventbrite? Just to show.
I think it's in my cache here. So
yes, exactly. So on the eventbrite.com, you can find data stacks, and there will be a button to follow. Bettina, you don't follow our events at Eventbrite. How could you?
I'm exposed. Okay, there you go.
So, and there are a lot of great events, Cassandra related, and not only Cassandra related, yes.
Okay. Cool. Yeah. And I think we've actually really run out of time. We're already 15 minutes over. There are some questions in there. I will go through them and just put some additional answers into Discord. And also, if you have still burning questions, then you can hit us up on community.datastacks.com, and then we will, answer them in much more peace and quiet and with a lot more detail. So especially these kind of questions are probably quite good for community. Okay.
Oh yeah.
I think that's really. Let me just have a quick look and show you in the presentation a few of the. Oops, I'm way behind because I did. The additional resources that you can have in order to continue learning. So I really want to show you the datastacks.com/dev pages. There you have a lot of hands-on examples that you can access, and they're with Katacoda. So you might enjoy that. These are just basically spinning up little Cassandra instances for you, and some of them also connect with Astra. So you can practice a lot of additional, also quite advanced concepts there. And then we also have our classic courses on DataStax Academy. And especially if you're interested in a voucher and want to pass the certification, you really want to check those out, right? Okay.
One more slide.
Good. Is there one more slide? Oh, yeah, additional resources. Yeah. So all the slides are also in the GitHub repo, right? And we will update them. Alex added some additional material today for the Cassandra overview. And so we will update those slides there. But and if you can't find anything that we discussed today, we are still available on Discord. This is up all the time and in the community.
Okay. May I have 1 second, because I see we still have people there and I want to have a word on one more thing. Just a moment. I'm switching. Yes, here we go. And
I'm really curious now what it might be.
Yeah, of course. Here we go. So, DataStax Monday Learning. We haven't mentioned that today, but now we have workshops not only on Wednesday and Thursdays, but also on Mondays. Mondays are used to be the worst days of the week, and we are going to change that because we are going to energize every of your Mondays with some great workshop about some topics, what's the most important for developers from our point of view. next 4 weeks, well, first workshop is obviously done, but you still can watch the video and do the homework and jump in is the Docker learning path. We are doing this workshop this week and next 3 weeks, and all the information at our Eventbrite page where you can subscribe to all of our events. Thank you so much. Bettina, I'm switching back to you.
Oops, I don't have anything else to show.
Okay, so we are done.
I mean, we have things here, but I think we're really out of time. So thanks everybody for coming today. And I've just looked at the wonderful comments in the video, in the YouTube chat. Thank you so much for all these wonderful comments as well. It's such a pleasure doing these workshops, and I hope you learned something. And I hope to see you all again.
Yep.
Next week we're Monday, Tuesday, Wednesday, Thursday. We have 4 days of workshops next week, so hopefully you make it to one of those.
Thank you so much. Thank you, Bettina. And see you later, maybe Monday, maybe Wednesday, but we always have something special for you.